Today we're talking about principles of safety. Well, basically, I guess the TLDR of this is, what can we learn from people who recover fighter jet aircraft aboard an aircraft carrier? Quick starting out just to say, my views, pictures, all these things, they are, number one, not approved by the US government in any way. They also are all declassified, so it's safe to watch this and no one will come after you afterwards. All right, just quickly and briefly here, our flight plan, what we want to do today and talk about. It's good to have a flight plan if you're flying, right? You want to go somewhere. We have an introduction, which is what we're in now. We're then going to consider briefly the pilot perspective of landing on an aircraft carrier, kind of important. The LSO perspective and kind of learn what they are, who they are, and what they do. And then we're going to hear about some sea stories. This is, I think, the meat of where we want to hang out, learning about how do they compare, contrast, and hearing cool facts. Hopefully all of it will be cool, right? Goals of the talk, obviously, just to kind of have an appreciation of the complexity of a different occupation is something we can learn from. But in hearing cool stories and things, hopefully we can glean a few stories and nuggets of truth via illustration from this. So quick question before we start. How many of you guys have seen Top Gun original, the new one? Yeah, all right. So you're in the right place for this talk. Absolutely. OK. So the first thing you have to land on an aircraft carrier is an aircraft carrier, right? The naval aviators jokingly call it the boat. It is way bigger than a boat, but that's what they call it, right? They have a sense of humor, these guys do. So let's understand what it is. Here are some pictures of aircraft carriers. Bottom right of your screen is going to be one of the first aircraft carriers ever. And then as you move to the top left, it's a weird order I put it in, but the top left is one of the newest aircraft carriers. Basically, some quick facts about them. The flight deck of the aircraft carrier is 4.5 acres large. It's huge. It is considered U.S. sovereign soil that can be moved anywhere in the world with under 2 days' notice, anywhere. It's pretty cool. 9.7 billion per ship. The U.S. has, I think, 11 of them, 12 of them, varying on the size of the fleet. They displace 106,000 tons when loaded. They're 1,092 feet long. Sorry, I mean feet, not meters. 252 feet wide. Has 2 nuclear reactors on board. 4 giant propellers that power the boat. Its top speed is 30 plus knots. It's 35 plus miles per hour. It can go an unlimited distance for 25 years without refueling. There are 3,500 ships company. That's people who run the ship, make it go, power it, things like that. And there's about 2,500 air wing personnel. Those are pilots, maintenance for the aircraft, things like that. So you got about 5,000 people, right, plus. There are 85 to 90 fixed-wing aircraft and helicopters on board when it departs and leaves port. Most of the ship is covered in 2.5 inches at least thick of Kevlar armor for obvious reasons. And then these ships do house the most advanced radars, countermeasures, and ship's defense systems available. And they do, as they float around the world, they control airspace generally in 600 miles of where they're at currently in that bubble. That's what they're aware of every flight happening in that area. So they're kind of a big deal, right? Here's some pictures of the flight deck of the ship, just to get used to it and look at it here. Let's see if this works. Here, I want to point out, if you look at the screen, on the back of the carrier, this is the LSO platform. We'll learn more about that in a minute. This is an important part of the ship. This is what you don't want to hit, the ramp. You leave from the front end of the ship here. There are 4 catapults that run, 1, 2, and then you've got 3 and 4. They're here. They're located right behind and along this area with these 2 white stripes on the outside and then the dash line in the middle. That's called the LA, the landing area. And then hopefully as you land, you need to catch, not hopefully, you have to catch one of the arrestor wires. There are 4 of them. Over here on the right side of the ship, your starboard side, you'll see the aircraft carrier island. This is where you have all of the command and control functions happening. And then the other little places that are highlighted on the ship are just different areas. You'll hear pilots say, hey, we're going to respot to the 6th pack, which means move your airplanes up to that point. There's a lot of shuffling that happens as they prepare to launch aircraft. As you can see on the picture on the bottom right, that's a lot of airplanes on there, right? And they have to get all of those off. It's like playing a giant shuffleboard, right? All right, so landing at the boat, here we go. What does it take as a pilot? So first of all, you have to understand and know what you're doing. There's a thing called NATOPS. That stands for Naval Air Training and Operating Procedures Standardization. This standardizes all aspects of procedures and gives rigid guidelines for safety of flight and operations as you operate these things. As you can see, there are 3 different ones I have on the screen here. There are a lot more than 3 in real life. These are just the 3 that I think that are the most relevant to our talk today. I thought I would just show you. Okay. All right, here it comes. I'm going to boil down. Each one of those manuals can be anywhere from like, thousands of pages down to a couple of hundred pages to like consume and learn. So a lot of reading, very interesting reading. But we're talking about landing, nothing else. We're going to limit our scope to that, right? So here's a case 1 recovery. This is case 1 in naval aviation. TALK means daytime landings. These are optimum, in our terms, golden path, best conditions possible. This is how you land on a boat. Diagrams, there's going to be a lot of them. The goal is not to understand them all. I'm going to run through it quickly by giving you a story of how you would land. All right, so you're coming in. The first thing as a pilot you're going to want to hear from the ship or understand is obviously where it's at. You would do that through what's called a TACAN, Tactical Air Navigation Beacon. It literally tells you how far you are from where the beacon's at. And you get that on your HUD, your heads-up display in the aircraft. So you can know I'm 30 miles away. The ship itself is called Mother, so you hear all radio communications referencing Mother. That is the aircraft carrier herself. Final bearing and base recovery course are the other 2 important concepts before we launch into this. Base recovery course is like the direction the ship is going. Like I'm going, like if it's going north, then the base recovery course would be 360 or 0, right? Your final bearing is important as an aviator because that is the direction on that picture of the aircraft carrier you saw. The ship's going this way. The landing deck is going about 9 degrees this way. So as you approach from behind the ship, you're not landing straight with the ship. You have to calculate for that 9 degrees off. So they'll give you that, especially at night when you can't see it coming. They're going to give you that final bearing. That's usually communicated to the aviator in the cockpit. All right, so you're flying back from your training mission, strike mission, whatever you've been doing, flying onto the boat. Between 150 nautical miles away from the boat, you have to check in. That call would typically be the following. Courage Marshal 403, marking Moms 270 for 65, Angels 10, State 5.6. Said a lot faster than that, and they understand it because they do this all the time. What I just said, though, was Courage Marshal, that's the boat, the Marshal Department of the boat. They're in charge of stacking aircraft for recovery. You then give your side number, 403 would be mine, like every aircraft has its own number on it. I'm marking Moms 270, so I am on the radial, 270 out from Mom for 65, that's miles. I'm at Angels 10, that's 10,000 feet. My state, something you're going to always be asked for in every communication piece, is what's your fuel state? Like fuel is life, right? 5.6. That's 5,600 pounds of fuel. Then the air marshal will talk back to you and say, hey, report see me at 10. And that means tell me when you're 10 miles away. At 10 miles away, the contract you have with them is that your hook is going to be down. You will be at the correct marshal altitude, which is that area. Once you're inside of 10 miles of the carrier, this is a very busy airspace, right? So you have to be at your assigned altitude by 10 miles with your hook down. That's the contract. Then you report, marshal, see me at 10. Then you're going to join into the marshal stack. Basically, that's the diagram here you're going to see here, that green ring flowing around the boat. It's offset. You never can be more than 5 nautical miles away from the boat, max. You're going to come in and you're going to be flying that green circle. Notice the ship is offset to the right side, right? That's point 1. You're going to fly, every squadron is assigned a certain altitude in there. On a typical recovery, you could have planes stacked from 2 to 20,000 feet, and then usually in pairs. And then you're going to hear over the radio broadcast out, Signal Charlie. Signal Charlie means you are cleared to land, like go ahead and start bringing planes down for recovery. So most times this is done in what they call a zip-lip fashion. Nothing is spoken on the radio. If you're out at sea in an area where you don't want to be found, radio communications is the worst thing you can emit, right? So it's usually done quietly at daytime. So these planes will all stack. They're going to raise the Charlie flag on the carrier, a little flag. The person who's at the bottom of the stack, usually 2,000 feet, sees that flag. Here I go. If they don't raise the flag, typically they can watch. And then when the last plane is launched off the front of the deck, within about 45 seconds, they are beginning to recover. So as they get in the last planes lined up, those planes are descending through this process we're going to go through in a second and preparing to come in for recovery. Quick note, from points 1 and 3, so the front half of that circle, you are allowed to climb. Once you are between the back side of that circle, you can only descend. That's one of the rules of the game here, right? Yeah. So here's another diagram. This is going to be the close in here. You're going to come flying in here. Once you've been given Charlie, or you see that it's time for you to descend, you're going to come out and descend. You're going to go down now to about 800 feet as you fly in around the carrier itself. Make your brake turn. You can see here I'll reach the level brake. Right before you do that, though, when you're on the ship, you're going to start this. The ship will be on your left. You want to make sure the deck is ready for you, first of all, so you don't have a problem, right? You also want to make sure your master arm switch is off and that hook is down at this point. After that, it's too late. Like, you're going to forget about other things that have to happen. So you're coming through, you make your turn 800 feet. As soon as you start that turn, you're going to put speed brakes on full throttle, full back. You want to basically go from 350 knots to about 140 knots to get the F-18 under control, so it's not squirrely on you, right? You can do that, and once you make that turn, you will then deploy your speed brake back in. Your landing gear will come down during the turn. As your speed descends, you can't have your landing gear or flaps down below 250 air knots or they will be damaged. And then you're on that final approach there. You'll be flying the reciprocal course of the ship, so the ship will be heading this way past you, and you'll be coming on this side. At that point, you want to be at 600 feet, and then you'll commence your turn when you are abeam the ship. That means that little blue line you see there, that's directly over to the landing signal officer's platform. When you see directly to them, you begin that final turn in, and this is where it becomes very important and very dangerous as a pilot. Then that turn is a 27 to 30 degree bank as you come around in behind, and then we're looking for you to descend through that turn. You then want to intercept your glide slope, and then at 3/4 of the mile, you're going to see this. So you're coming in, that top left picture is 3/4 of a mile. You're seeing the landing area come up. You then have to make a call on your radio, and you say your side number, 403 Hornet, your type of aircraft, in this case an F-18, so 403 Hornet ball 4.7, really fast, say that really fast. What you indicate is, this is my plane number, this is my type of aircraft. That's important so they know your exact weight. These wires are tensioned on the deck. If you're too light, too little, it can like snap you, not arrest you, like large margin for error there, right? And of course, 4.7 is your fuel state, right? So now you're in the, now this begins what they call the groove, your final 3/4 of a mile. It takes about 20 seconds to do this. Super like intense time though, right? This LSO person you're going to talk to is going to respond to you. So when you make that call, you're going to hear back, Roger ball, and that means that they see you, we're talking, they're tracking you, right? As soon as then you're going to fly that right in, watching what they call the meatball. We'll talk about it in a second. There's a little like glide slope indicator. You're going to come in and land. It's a controlled crash. There's a joke they say, Air Force pilots land, Navy pilots arrive. You're going at about 850 feet descent per second, or per minute when you hit the deck. So it literally is you crash into the deck and that hook catches the wire, right? If you don't, that's what you call a bolter. The hook could skip across the wires, and instantly, as soon as you make contact with the deck, it is SOP. Throttles go into full afterburner or mill. Every time. Even if you catch the hook, you'll see the plane's full burners because like if you don't catch the hook, like you need that speed to go back around, right? Because you're going to flip off the deck. The other thing that can happen to you here that's important is a wave off. That's where something has exceeded a safety parameter of flight. The LSO is watching. We'll call wave off, 403 wave off. And then that, if it's really bad, they maybe start yelling and screaming, wave off, burner now, because like something is really bad happening. Like you're about to collide, hit the deck. Maybe someone has walked into the landing area. Things can happen, right? And so then the LSO's job is to wave people off. So that kind of is where now we've melded that LSO experience with the pilot's experience, right? So I can show you this in real life. Things to note in the video, we're going to take this video right here and pick it up where he's in that final groove turn to come in behind the ship. This is ziplit, daytime, so you're not going to hear any radio comms. He's flying and done all of this without a radio comm. Notice too that he's coming in to land. It's hard to see the first pass, but there's going to be a plane flying really fast right over the top of him on the right because there's other planes coming in behind. Like in the landing pattern, you're landing and recovering aircraft every 45 to 60 seconds. So you literally touch down, get stopped. There's a flight director saying, like, get off, get out of here, and you gotta fold your wings up and get out of the way because there's another guy right behind you, literally, right? And then as you land, you'll see at the very end, there's another aircraft, an E-2 Hawkeye that's spinning up. He's already to shoot off the front of the ship. So as you're recovering, it's a very fluid thing because an aircraft carrier is most vulnerable when it is recovering and launching aircraft because it has to fly into the wind. The best defense for a carrier is to zigzag and make erratic movements, right? Because it's hard to track and like watch. Like it was here, and now it's here. What was its speed? You can't compute that if it's zigzagging. So the captain of the ship will call, "Hey, air boss, you've got 15 minutes to recover ships or airplanes. Here we go," and they got to be ready to go. And then he quick resumes on that erratic course of the ship. Here it is. He's rolling out. When wings come level, that's considered the start of the groove. He's now in the groove. If you watch on the left there, his hand is moving on that throttle. Lots of minute corrections as he's coming in. He's tilting. No ball call. Zip lip. Here's the arrival. You've got a guy down there waving his hands, so you've got to move. He's going to fold his wings up as long as they get the hook lifted up off the wire. And he's going to taxi out. There's that E2 spinning up on the right to take off. I don't know if you guys saw that plane coming overhead. That's a recovery. Super intense, a lot happening there in just a few seconds, right? So what do you do now if it's bad weather or it's like nighttime? Because they don't just like have to do things while it's daytime, right? So this is called case 3. This is the worst or least optimum conditions to recover a fighter aircraft. I'm not going to go into this because it's super complex, like how to fly this pattern. The trick, though, or like the basic how this works is you'll start up with all the aircraft they're going to land. They're going to be stacked up behind the ship. The first one will be at 6 miles behind the ship, 21 nautical miles behind the ship at 6,000 feet. The next aircraft would be at 7,000 feet, 22 miles, then 8,023. As you see, they literally create this staircase stack of aircraft. And then as they start, you'll check in, they give you an approach time. So literally that distance and altitude you've been assigned from the ship, you have to be at the exact approach time, like within a second or two, because as they start descending this stack and collapsing it, it's literally every 60 seconds, even at night, they are recovering an aircraft. So there's no messing around. And then if someone does, we have a problem, people can get switched and they have to switch the whole stack, and the comms is like crazy. It's like watching TCP dump, like, but with people's voices, right? Because it's just like, okay, now your Rolex, your this time is this, and your 403, your time is this, 405, your time is this. It's like, wow, so just don't mess up, right? Like, hit your approach time, right? And then you come into the ship. It's scary, crazy scary. It's dark. The one thing you do have at night is you do have what they call ICLS, the Instrument Carrier Landing System. It gives you that whole needles with a circle, so you can kind of like follow the needles and put it where it needs to be. But if it's at night and let's say it's snowing or raining at night, your visibility is like 10 feet in front of you, maybe. And all you get some needles, like, that's not good. I mean, this can be really scary, right? And we will see that here in this video. It's going to look black when it starts. I swear this guy's on recovery approach. It's like you're going to have to wait and see like till the very end, like when it comes. So the video is playing. And there's some comms in this too. You can see. Hornet ball 5 Called the ball, means he's at 3/4 of a mile. Still at 3/4 of a mile. Oh. Power. Somebody called for power. That's an arrival. When you heard the beeping, that was him hitting the deck. That was his radar altimeter saying, like, you are at 0 feet now, like, hooray. And at that point, you're seeing him here. At night, the same thing. That's the sound of his wings folding, his flaps coming up because he has to get out of the landing. Another ball call right behind him. So there's more aircraft like coming right behind him. You can do 12 to 14 at once, maybe even higher. Super intense. And he's taxied now out of the landing area before he shuts his video off. That's a nighttime landing, right? Whew, a lot going on, right? It's crazy. It's really crazy. Here is a bad weather landing to say this is daytime. It should be great, right? What if there's clouds and fog and rain, right? There you can see the crosshairs of the needles. He's trying to get that circle moved on right onto those crosshairs. Oh, I see the tower. He still can't see the deck. Oh, there's the deck. I'm on the deck. So obviously, this is when you definitely want to, like, I'm in burner. I'm in, like, max power. I'm hoping the deck's there. If it's not, we're going around. It's not uncommon for LSOs to have to be watching and listening with their ears because you'll have pilots who come out of the fog and they're like way off course. So they're literally like seeing the tower of the carrier. And they're like, and then there's some crazy things. You can look on YouTube and see it. It's pretty scary and hairy stuff, right? All right, moving on though. These LSO guys, this is what we're here to talk about, right? Like the pilot part is really hard too, but then there's these people who have to like control all of this, right? Just in that last like life or death moment of like coming aboard, right? So a landing signal officer are people who do this. Their call sign or their nickname, you're gonna hear them called is paddles, right? Their mission is, literally, in their book, in the NATOP, says the safe and expeditious recovery of aircraft. Their motto is rectum non bustus. Not making it up. Literally, that's what it is, right? You don't want to bust the rear end of the ship, or go be the one to do it, right? So what's the job recs for being an LSO? So they literally, you have to be a keeper of the culture and safety guidelines and the protocols. Remember that safety regulations for these folks are written in blood. Someone has died or something bad has, we've lost a ship, then that rule gets added back into the NATOPs. So this is a very, very we had an incident like the jelly talk today, right? Like, well, maybe we did something about it, maybe we don't. All of these things that happen are like high priority, right? To the point that if something is found to be wrong, like maybe an ejection seat didn't work when it was supposed to, they will ground all those airplanes in the world and say they don't fly. And you can't just have a carrier deployed trying to do mission critical things saying, oh, all of our strike aircraft can't fly today. Doesn't go very well, right? So it's super important that they have these and they keep this culture and safety guidelines together. These guys also then take what they've learned as they've done and honed this skill, they take it back to Big Navy, the people who write rules, regulations in general, even larger than just them in their local procedures around the carrier, and they can get things added to there as well. They also then drive how this protocol, new things get added into the schoolhouses. They have schools that teach different things in the military. They have an LSO one, but they actually will say, hey, we're seeing pilots that are not flying this pattern right because of this tendency. We should go to the pilot school and tell them, hey, let's focus and emphasize on this as we bring new pilots through the course, right? To be one, you have to be technically, or you need to be a fully rated carrier pilot who generally has 1,000 or more hours of flying, on deployment. So these guys have a lot of time, right? You can be a junior pilot who's selected as well, and they do have a schoolhouse they can send you to learn this craft. But typically these people are going to be guys who've done this for a while. They know it. These guys know aircraft so well. They literally, if it's foggy, they can listen and say, I know what aircraft this is. And they can literally give them power calls and things based off just what they're hearing, which is just mind-boggling, right? Here's the quals you can have. So it's a very interesting process they have. You have a squadron qual. That means squadron would be your own similar type aircraft, right? Because there's lots of different aircraft types that fly in an air wing on a carrier. Several squadrons make up an air wing, and an air wing deploys to a carrier, right? So you learn how to wave or do your own aircraft type first. That's level 1 junior level, right? Then you go after the wing qual. That means that you can then successfully help land everybody on the ship, all planes you could help come in. When you do this, though, you have to have another wing LSO with you, supervising you at all times on the platform. And then you can get proficient there. And then a staff qual, that is reserved for the senior LSO in the carrier air wing. They call him CAG Paddles. He's responsible for training and qualifying all the other LSOs on the ship. And he's also has some other responsibilities we'll talk on in a little bit, but there's only 2 of them afloat at once on a carrier. So why paddles? LSOs literally, they wave paddles. You can see in the pictures here, when they first started doing this in World War II. I like the picture of the guy that he's in boxers only, and he's out there waving paddles. It's so hot, there's no uniform, just doing this thing, right? They then had to transition and go so it was a rite of passage. You literally made your own paddle, wrap things around it. Then they got to jet aircraft. Things happened a lot faster because they're moving faster, right? So then they had at night, you see the pictures, it's hard to see in the bottom left, but you see they had little Christmas lights almost on battery packs they had to wear on their bodies. So you could see them dancing at night and doing different things, right? That's why they call them paddles, because they literally have paddles, right? So let's look at the tooling LSOs use and see how that works. So the first thing they have is called the meatball. What this is 2 green lights. You have a yellow light in the middle. When you say, I fly the meatball or whatever, that means you got to keep the yellow ball in between those 2 green datums, right? If the ball goes high, you're high. If the ball goes low, you're low. High is better than low, right? Rectum non bustus, right? So to say, and what that indicates is glide slope. So it projects that color of light through a certain glide slope off the back of the ship. And pilots are in that because they come in or out of it. That's how they're seeing that ball move, right? And they call it the meatball, right? Pilots, when they're coming in for landing, they have 3 things they focus on. Meatball, lineup, and angle of attack. That's what you do, and you're constantly scanning through those 3 things. Meatball, lineup, angle of attack. Meatball, lineup, angle of attack to make sure you land. Here's a carrier qual flight. You can actually see the meatball. You'll see it right towards the end here. You're going to see it's in black and white. I apologize. This pilot's going to be high. It'll be on your left-hand side of the landing area. There it is. The ball is high currently. He's high the whole way in, and it dropped right the last second. You hear him breathing, because that's a hard hit. You get a lot of G's pull when you hit that deck. That's just a student too as well, from a student carrier call. So next tool or place we head to, the LSO platform. They have an office on the ship, right? It's this little tiny platform, holds about 5 people on it. There they use the iLarch. You'll see on the bottom right, that's the integrated launch and recovery television system. That gives you that nice crosshair, and when the plane's coming in, it's easy to see. He's high, he's low, he's right, he's left, right? This is what their tool they get for observability, if you will, to see where the aircraft is at coming in and to make calls and things accordingly. He also has information about the ship on the perimeters of that screen, like how fast is it going, how many knots of wind do I have down the angle to report to the aviators. Also crosswinds, where is the crosswind coming at the ship at? It displays it on this screen for them to see. Yeah, you can see them all packed on the platform. There's the aircraft is landing above them there. Thing to remember is with this, when they're landing these things, this ship is moving in 3 dimensions at once while being propelled forward at least 25 knots. So that's moving. The aircraft is moving with wind of crosswinds and things. So that's why this is a hot mess right till the end. Another thing, let's see if I can get this zoom thing to work here. Instrument they have is on the aircraft right there. I don't know if you can see that little yellow light. That's an angle of attack indexer that has yellow, red, and green, right? That's going to, when it's yellow, that means the aircraft is in the glide slope correctly. Then as the pilot deviates, he has this information displayed on his screen as well, right? They call it flying the donut, because he has a donut with 2 arrows, and it helps him like line up onto that angle of attack. What angle of attack means is the aircraft, this is angle of attack, aircraft tilt, right? You want that aircraft to be tilted up so the fact that that hook right there you see is 12 feet off the deck is generally what they target. That's their metric for success. If it's higher or lower, you're not going to hit a wire. So that's what they have to target. And if the sea is moving the ship, they can also adjust the glide slope and the meatball. It's on a gyroscope, but there's certain tolerations that it can't handle when it's doing like 30-foot swells, right? Those are crazy too. Check them out on YouTube. Like when it's swelling at night, it's like, oh, there's a postage stamp. I see the whole deck, and all of a sudden it goes away. And you're like, what? So check some of those out if you're interested as well. But those are their tools. So we talked about LSOs for the quals. This is who's on the platform during normal operating hours, right? So you're going to have the carrier air wing LSO or CAG paddles. There's only 2 of them on the ship, right? And they're responsible for all training, and they're actually responsible for every single landing at the boat. So what that means is for every aircraft recovery, one of them has to be present. Every aircraft recovery. And that's like 24 hours a day, right? So like these are busy guys, right? Then you have a controlling LSO. He's going to be the guy out with, he's going to have a headset on, a telephone to his ear, and he's going to have this thing in his hand. He's going to be the one actually watching that plane, and he's the one in contact with the pilot, right? You're going to have a backup LSO right next to him, looking at the iLarts. This person's responsible for all of the aircraft coming in this low pattern here, up to the groove. They're making sure and double checking everything's good here. They're also double checking him and just keeping an eye as they're watching this, like, is he doing a good job? You know, like, they're backing him up, right, for the controlling person as well. Then you have a deck status LSO. We have a video here in a second to show you. But they're going to stand, if the airplane's landing this way, as soon as the airplane lands, he hops out in the landing area, and he's going to stand there and hold up his hand saying what they call a foul deck. That means the landing area is closed. Something's in it, like it's foul deck, right? He'll say that. His job is literally to watch backwards, planes coming behind him. When he sees everybody's out of the landing area, he then is going to walk back on the platform, physically touch, pat, whatever they'd want to do, say, I'm good, you're good now, you can land them, right? Because the LSO, the controlling guy who has this thing called the pickle in his hand, the pickle switch, that's a button, there's a switch on it. When his hand is up, the deck is foul. Once he brings it down, the deck is considered open to land, right? And if we have an airplane that's going to come in and have a problem, he can hit a button on that pickle. In that meatball glide slope, there's a whole bunch of little red lights you saw. Those flash in various patterns. They all come on when that means like wave off, like stop, right? So they can still issue wave offs and these commands through the lights when they have to be quiet because of radio comms, right? But the deck stats LSO is just there to make sure the landing area is not foul, right? Okay, here you're going to see them all at work. You're going to see one evolution, one plane come in. I think it's going to be hard to hear, but you're going to hear the guy actually lean over and start giving like. They give grades, like spoiler alert, coming up next, talking about grades. They give grades for every airplane pass that comes in. You'll see him doing that, and you're going to see the guy calling no foul deck and touching him. You're going to see all of that in action here. Paddles. CAG paddles is on the right there. See his shirt, CAG. He's the guy overseeing everything. He just tapped on the back. He said, "You're good to go." The guy there who's standing, he's touching right now. He's actually recording grades only. Controlling LSO just put his pickle switch down. He's got the phone up to his ear. We have the backup LSO right there as well. She's got her earphone up, but she's just more passive listening and watching. Here comes the plane. You can see it coming in for an approach. He's in the groove now. You can't hear him. He's calling out and saying, like, you're high, you're low power. Airplane landed. Instantly what happens? Foul deck, hands up, pickle switches up. A lot of power calls. And you have a guy going, "Federals, foul deck," right? That's how it works. That's their day. And they just do this over and over and over, right? All right, so they do grading too. Not going to get into this. This is a crazy, complex thing. What you're seeing, though, is a pilot trend sheet. So every single pilot, they get graded on. That's every landing you're going to see there on the cruise so far. They track day, they track night, and they're looking for overall trends of going, I'm trending safer in my recovery, or I'm trending like not safer, at which they're going to be given extra counseling and extra like daytime reps, right? You have to have a certain number of daytime and nighttime traps in a 14-day window. Otherwise, you lose your qualification. You can no longer fly when you're deployed. The overall goal of this is to keep the culture of safety high and detect problems really early so we don't end up in a mishap, right? Here you can see some of the grades, and this is how they do the grade. This is like table 1 of like 18 of them for like the little 4-letter codes they give you. In the bottom left, you're going to see, and there's these different points you'll see in the ship up here. Like they start grading you at the start, and they can give you like all these designations at every little segment coming in, and it's like, wow, this is crazy, right? But hey, culture of learning, right, and safety. I mean, there it is, right there, front and center, right? So I put a grade here at the bottom left. It's a little bit complex. I've seen worse, but this is 330, airplane number, right? He was okay with, so it means generally he had a safe pass, right? The best grade you can get is okay. Culture of learning, right? Like constant improvement. There's no like, great job, A+. Nope, it was okay. It was okay, right? And then the HX with the parentheses means he was high at the start, at the top. When the parentheses are around it, that means a little. So he's high at the start, but just a little, right? It's all these little notations, right? Then wings in the middle, he rocked. That plane was rocking a little bit. He was a little high and close, HIC. TMRDIC, he had too much rate of descent in close, which means like at the ramp, like, within 3 seconds of touching down, he kind of dropped really fast. That's really bad. You don't want to, they call spot the deck, right? And then he got graded in EGTL. He's going to get counseled for that one, right? He eased guns to land. When you land, your throttle should be constantly adjusting in the high end of the spectrum. This guy was like, I'm high. Pulled that throttle to kind of, caught it like that, right? Not good. That's super unsafe, right? But he caught a 3-wire. So there's these interesting parts of the grade. The 3-wire is the wire you're supposed to target. That is the safest. 1-wire is a cut pass that's super bad. You're going to get talked to by the air boss, right? A 2 and a 4 are okay. 3 is the best. So you'd say, hey, it was a great thing. But he had some things to improve on, right? Here's the squadron ready room in the top left. They do track these. It's very competitive. That's what they call the greenie board. They put that's every landing pass with the color of the rating of the grade. And at the end of the deployment, they'll have awards you can win, like I was the best tail hook and these different things, right? So they grade you on your safety, but also your boarding rate, like how many times did you actually catch the wire without having to go around, right? So now you understand LSO a little bit and how to fly. Let's draw some comparisons. This is the meat of it here. Quick side note, they have a thing like we do for tech stickers, and they're patches for their uniforms. It's crazy. There's stories, they'll take these and they wear them on like one of their shoulders, right? They can trade these for things on the boat. Like, hey, I want an extra pair of boots or things that I'm not supposed to have. I'll give you one of my flight patches. And they're like, what you need, man, I'll hook you up. That's kind of a thing that can happen, right? It also is conveniently possible, that little yellow light we looked at on the AOA indexer on the landing gear, I've been told that with a case of beer, you can get one of your maintenance guys to kind of make sure that light does not work when you try to land, so the LSO does not get that extra information. Which is a safety concern, but then they can't get, there's like more ambiguity to the grade. Anyhow, we all have standard operating procedures, NATOPS. We have these things, right, that we can read and learn about. Mission statement, kind of the same thing. Like, They say, through training and experience, LSOs are capable of correlating factors of wind, weather, aircraft capability, ship configuration, pilot experiencing, et cetera, in order to provide optimum control and assistance in aircraft landings. The pilot and LSO form a professional and disciplined team, both ashore and afloat. The LSO strives to develop the pilot's confidence, judgment, maximum effort, technical proficiency, and personal interest. The pilot must rely on the LSO's experience and ability to prepare him for optimum effectiveness as a carrier pilot. I feel like we should substitute some of those words. Maybe that's what we do as SRE. They have means of communicating. There's your AOA index on top left, how that all works, right? But they have tools to see how they're doing, observability tools. So do we. Documentation. We all have documentation. I'm working this right here. I'm working it, right? Like, okay. We're getting there, right? They all have measures of success that are clearly defined, right? Boarding rate, grades. We have these things, right? Like DORA metrics. I'm working here. We have incidents and mishaps. Theirs obviously are way more higher consequences than ours are sometimes, most of the times when life is involved, right? We all have grading and measurability things, right? We can grade the maturity of our services. They grade their maturity of their landings and their development of individual pilot skills. There's the similarities, right? Here comes the C story, is the best part, right, though. So let's talk about this. Usually, by the way, when you talk to a naval pilot and they're like, tell me some sea stories, these are like, tell me your really harrowing, really cool, awesome moments, right? They're mostly humorous and off color. That will not be the case today. But we're going to try to formulate some principles here with our last few minutes. First one is, what can we learn? Communicate with intention. They have a saying, don't talk the pilot off the wire as an LSO. As the pilot's landing, you got to remember, these guys have probably been doing it for a while. They know what they're doing. They're seasoned operators. You sitting there going, you're high, oh, now you're low, now come right, no, left, no, up. That's not going to help them. They know what they're doing for the most part, right? Don't talk them off the wire by over-communicating, right? So be intentional is what I'm getting after, right? They have a thing with the sugar calls, too. These guys have been doing it for a while, so give them you don't say, hey, you're looking good. That's never said, right? That's wasting air traffic or time on the radio, right? You don't do that. But maybe they're lacking in confidence, so a sugar call is like, keep the power on or keep it coming. Typically that's what I hear a lot. Keep it coming. That means you're doing okay. They build confidence for people who might be struggling as well. Especially if some of these guys, if they try to land and they're having a bad day or the ship's moving, they might try 7-8 times. And a lot of times they're going to run out of fuel and have to go tank to a tanker before they come back and try again. So they're probably shaking at this point with adrenaline, right? And these guys are giving them some sugar calls, right? So as SREs, how can we translate this principle to us? Maybe we should not be overly prescriptive with developers or people we work with, right? Teams, partners. We should be working to talk them through the situation, an understanding of why and how to do things to help them make the right decision the next time, right? Specific language is important. That's my next one. So avoid mangled or misinterpreted comms, and your jargon works when standardized is what's on the slide. So you'll see these sayings here that we've superimposed over the screen, right? They literally have specific things they can say when they're giving calls to pilots because the radio could go out you couldn't hear them, right? Or if somebody by accident squawks over them, they can't hear it. So as an aviator, you know if someone needs to come right for lineup, so if the airplane is where that is, that's what you would say, right? So if the pilot was over to our right, their left, you would say right for lineup. If they're on the left, you're going to say come left. You would never say left for lineup, and you would never say come right. So if you heard come, the pilot knows instantly, I got to go, come left. That's what that means. They literally keep this jargon specific for that very reason. And you're never going to say too much power, you're high. You're going to say you're high, or if you're low, power. These are the things you can say. And they have all these prescribed of when they can be said, right? So how do we translate that to us? We should be calling out things, I think, that are uniquely, so standardized comms that we would use can lead to high unit effectiveness in our businesses, and our mission success as businesses can be more critical. And what I mean by that is help other teams learn how you say things like DORA metrics, or what's latency. These kind of things should be communicated out. So if there's an incident, everybody in the business can understand what's happening, and not have to ask questions. Wait, what does that mean? That slows down your mission capability, right? And everybody can be on the same page with their technical jargon. It is important. Second one, build a culture of safety and reliability. So LSOs go down to the ready room after each recovery period, and they're going to brief their pilots and give them their grades and be like, dude, you were crazy high. What's going on, man? Are you okay? They're going to go through all this with them, right? And as they do this, there's a shared principle that they take away from what the Navy calls the Navy Fighter Weapons School. You've heard of it. It's called Top Gun. One of their main principles is when you're briefing or debriefing, all rank is checked at the door, whether you have stars on your lapel or not. If you're a lowly ensign or a lieutenant JG or you're an admiral, when you walk into a briefing or debriefing room, no one cares. You can literally go to an admiral and be like, you, sir, did not fly that correctly, in a kind way, but like, you were not safe because of this. That's just how it is. We should emulate that, check our rank or experience at the door when we talk about debriefing or incident reviews, or as we just, it's obviously a good practice for any time in your life to be kind, but I think it's important for people who are more junior or senior to have, everybody has an accurate voice, I guess is what I'm getting after, in a briefing or talking about incidents or things like that. Watch our tone, how we approach that. That, I think, promotes a culture of safety. Everyone can learn from it, feel free to safe to talk in. Here's a quick one. You'll see this carrier pass on the right. This is an actual picture. It's in the news a lot. It's not photoshopped. It is real. There's like, how is this possible? This is completely unsafe. This guy was literally 5 feet off the LSO platform doing a knife edge pass, like on his side. Not safe. And the guy who flew it was Dale Snodgrass, who recently passed away. But he said, he writes back every time when someone posts this picture, like goes off on it. He said, guess what? The guy with his hands folded there behind the LSO platform, he's actually the chief of naval operations for the entire Navy. Like, he was there watching. He was preparing an air show that they give on the carrier while they're afloat to the families. He was allowed to do this, right? Because he was a demo pilot. He had more experience. He had more like understanding of what was happening. They would not let a Lieutenant JG, who was just a normal flyer, go and do that. That isn't safe, right? How do we translate that? We should know our developers and their tendencies. We can give latitude to those with experience, and we can definitely help coach those who are more junior. Just don't come down on them, right? Teach them, work with them, coach them would be a good word, right? Next principle, be an expert. So whose job is safety and reliability, right? It's everybody's is what they would say, right? But at most companies, that's an ambiguous definition, right? LSOs take on that role voluntarily to go and help promote and safeguard that culture. That's something that we can volunteer for, right? Know your business acumen, right? So that you know why something does or doesn't tie to your company's bottom line. LSOs know that, right? Getting people aboard. Here's Pryfly. This is on the top of the tower. It's hard to see, but you're way up high, right, on the flight carrier deck. What's important is these books you'll see here, right? When you're deployed, the NATOPS for every squadron aircraft is right there. And when they're having flight operations occurring, a squadron member who's not flying, who's off duty, is standing with the air boss and the mini boss. They're in charge of all flight operations. Anything that goes in the air, they're in charge of it. The ultimate buck stops with them. They have a squadron rep there. If something happens in flight, I'm leaking oil out of my left wing. Like, what do I do? The pilot can't troubleshoot that while he's flying, right? So what he does is they call in, they have a squadron rep, someone who's very knowledgeable and who's there, who can get on the radio and say, hey, buddy, I got you. Let me look this up. All right, here's the troubleshooting steps, right? Let's go through it and let's work through it, right? Be one of those in your company. That's what I'm after. Be someone who knows a lot, is not just there to get a promotion, but someone who's very willing to be the first to help coach and train and be that expert. Fly the meatball. LSOs have the ability to determine whether a deck is fouled and closed and they're waving people off, or if it's clear, right? They also have the ability to, at any point in the landing, the paddles can take over and say, he'll call out the aircraft number 402, paddles contact. That means, whoa, like paddles is watching me now. They do this sometimes if like somebody's having a problem or like, something's happening earlier in the pattern than they would normally Roger Ball, give them a call. Be that person on your team who's able to say, oh, I see a problem coming. Call paddles contact in your org, right? Keep the focus on like, here's how I'm going to prevent something happening, right? I see this trend building up. Like, have that technical ability to do a wave off too if you need to, right? And the voice to say that. But with that comes that trust, though, of being an expert, right? To be able to do that, you have to earn that trust, just like LSOs do. Another thing briefly, LSOs work in pairs. Like, I don't know how many of you consistently have working as pairs as like a team like charter statement. Highly recommend it though, right? Last thing is, it's important to remember that as with technology, it's not about building a better airplane, it's about teaching the pilots and coaching them. So remember that as you work with people, it's not a machine you're working with, it's people. People are the hard things, right? Continuous learning. Anyhow, hopefully all this sounds a little bit like it came in together and you understand it. Hopefully you can think about it and find more ways in which you might see LSOs as SREs and how our cultures jive together. And if you're curious about this whole flying thing, want to hear more cool things, a quick shameless plug, there's a Fighter Pilot podcast you can listen to. Highly recommend it. Crazy story, a lot of sea stories in there, right? And things you can hear about. If this talk content was awesome to you guys, I would recommend this thing because it's way better. Anyhow, thank you for your time. I appreciate it. That's my talk.